All right, starting lesson 10.2, finding the area of irregular shapes or the shaded region. All right, here's the big idea. There's a particular analogy I like to use for all these problems. Think of the shaded region problems as if you were working with cookie dough. All right, you are usually cutting one or more shapes out of another bigger shape, and you are trying to determine how much dough is left over. Or in this case, it's going to be the area that's left over. So example 1, find the area of the shaded region. If possible, leave your answer in terms of pi. This means that if you have pi, when you're working out the expression and simplifying it, don't plug in 3.14 for it. Just leave pi there. All right, so what do we have here for part A? We have a square. And what are we cutting out of this square? We're cutting out a circle. And we want to know what this area is here that's left over. Oops. Okay. So what's the big idea? So the total area is equal to whatever the area of the square is minus the area of the circle. All right. If you understand that, then you're on your way. So what is the area of the square? The area of the square is going to be 10 times 10. Or let me go backwards a little bit. Backtrack here. This is base times height, and then it's minus pi r squared. Okay, what's the base and the height? 10 times 10. Minus pi. R in this case is what? Well, the radius goes from the center to the outside. So if this length here is 10, then the radius must be 5. So we have 5 squared. All right, so we have 100 minus 25 pi. All right, and that's all there is to it. So we could plug in 3.14 for pi, but since it says leave your answer in terms of pi, we don't do that. We're just going to write 100 minus 25 pi. All right. If any part of this does not make sense to you, ask for help right now. All right, let's move on to part B. All right, so part B is not much different from part A. All right, now we have a rectangle to start with. So it's the area of the rectangle minus what? Well, what are we cutting out of this rectangle? We're cutting out 2 circles. So it's the area of whatever the circle is times 2. If you understand the setup, then you're on your way. So we have base times height, or length times width for the rectangle, minus 2 times pi r squared. So the base of the rectangle is what? All right, you're going to have to think a little for this. So the radius is 4. That's the radius of 4 as well. These circles are identical. That's 4. And that's 4. So going all the way across, that's going to be 16. The base is 16, and then here we have 4. Radius again is 4. The diameter is 8, so this length is 8. And we have minus 2 pi r, which is 4 squared. All right, so we have 16 times 8, which is 128, and then we're going to subtract 2 times 16. Make sure you don't write 2 times 8 here. 4 squared is 16. 2 times 16, which is 32. And we're going to leave our answer like this. Leaving our answer in terms of pi. Done. All right, for part C, we have a donut. We have a big circle, and we're cutting out the small circle. And this is what's left over. All right, let's figure out the area of the donut. So area total is equal to, let's say, area of the big circle minus the area of the small circle. All right, so we have pi r squared. I'll put a little subscript here, b for the big circle, minus pi r sub s squared. All right. So the radius for the small circle. So I have pi, the radius of the big circle is these two combined, right, it's the whole thing. Make sure you use the whole thing. It's 6. Right. So we have 6 squared minus pi. R for the small circle is 3. So it's 36 pi minus 9 pi, which is 27 pi. All right. Next one, part D. All right, what do we have here? We have a square, and we're cutting away these two triangles. Okay. So our setup will be the area total is equal to area of the square minus the area of the triangle. But how many triangles are there? There's 2 of them, so 2 times the area of the triangle. So I'm going to have area of the square is what? Well, I have these tick marks here, so if that's 6, that's 6, which makes this whole thing 12, and that's 6, and that's 6, that whole thing's 12. All right, so I'm going to have 12 times 12 for the area of the square minus 2. I'm going to put the area of a triangle for me here. Half base times height. All right, that's the area of a triangle formula. So I have 144 minus 2 times a half. What's the base of the triangle? The base of the triangle is 6. And the height of the triangle is 6. All right, so I have 2 times a half. All right, make sure you're not distributing here. I see some students doing that. And you're only distributing when you're working with a sum or a difference. All right, when you're multiplying, you just choose 2 numbers, and then that's it. Make sure you don't distribute. So I have 144 minus 2 times a half is 1, and I have 6 times 6. That's 36. So I end up with 108. And it's going to be yards squared. That's my area total. All right, let's go on to some more examples. Example 2, find the area of the shaded region. If possible, leave your answer in terms of pi or in radical form. Okay, let's see what we have here. So this example is very similar to the first example we did in the lesson. It's just taking 2 different sized diagrams and combining them together. All right, so area total will be equal to, I'm going to put in parentheses, it's going to be area of the, I'll say the small square minus the area of the small circle. And that's going to be plus the area of the big square minus the area of the big circle. All right. So now I have the small square. What's the area of it? Let's see here. This is 4, so that's 4, which makes this whole thing 8, which makes this 8. So I'm going to have 8 times 8 for the small square minus pi r squared. What's r for the small circle? 4 squared. All right, got all this here in parentheses. And it's going to be plus, what else do I have? For the big square, this is 7 here. So the whole thing going across is 14. So that's 14 here. So 14 times 14 minus pi, and r for the big circle is 7 squared. All right, let's simplify all this. So I get 64 minus 16 pi plus 14 times 14, that's 196 minus 49 pi. All right, now since there's a plus sign in front of the parentheses, that doesn't change anything. It's just multiplying by positive 1. So I could drop all the parentheses, and I could add these like terms here. which gives me 260. And then I have negative 16 pi minus 49 pi. This is where students do all this work, they're getting everything, and then they forget the negative. Watch out for it. All right, so negative 16 minus 49 pi, which is 65 pi. All right, and that's your area total. There it is. All right, for the next problem. The figure below is a regular hexagon. A regular hexagon can be divided into 6 regular triangles. What does regular mean? It means all the sides and all the angles are the same. Okay, we want to find out this area here. All right, so this hexagon can be broken up into 6 regular triangles, but I only want to know the area of 3 of them. All right, so I just need to figure out the area of the triangle, essentially. So the area total is equal to, let's see what we have here, 3 times the area of the triangle, right? All right, so it's 3 times 1/2 base times height. What's the base? What's the height? All right, I already have the base of the triangle. It's 6. What's the height going to be, though? All right, this is where you're going to have to think back to regular triangles. If it's regular, all these are 60, which means that's 30. So now just focusing on this triangle here. This part right here is 3, which means the height will be what? It's going to be 3 square root of 3. All right, and that's all I need to solve this problem now. Because it's a 30, 60, 90 triangle. So I have 3 times 1/2 base, which is 6, times the height, which is 3 square root of 3. All right, so now I have 1/2 of 6, which is 3. Lots of 3's here. All right, so I have 9, 27, 27 square root of 3. That's the total area. And it's just units squared. Done. And the last example. What do we have here? Well, we have a square with a 1/4 of a circle cut out of it. But this 1/4 of a circle is a much bigger circle. So let's think of it like this. Could think of it that way, right? So we have this circle here, here, here. All right. And so what's the radius of this circle? 9. Okay. So I'm going to backtrack now. And what's my formula going to be? Area total is equal to area of the square minus, how much of a circle are we cutting out? 1/4 the area of a circle, a 1/4 of a circle. All right, so now I have base times height for the square minus 1/4 pi r squared. Now, the base and the height are both 9 for the square, minus 1/4 pi. Now, what's the radius for this circle? As we stated before, it's going to be 9, okay? Because we have this whole circle here. All right, so we have 9 squared. So I end up with 81 minus 1/4 pi 9 squared. 9 squared is 81. So I have 81 over 4 pi. Okay, and it says to leave your answer in terms of pi. So there's nothing else we're going to do with this. We're just going to leave it as is. You could divide 4 into 81 and write it out as a decimal, but this is good. This is just fine. All right, if you have any questions, please make sure to ask. Begin the assignment.